Hi everyone, let's continue on with conservation of momentum and this time look at collisions in 2D. I'll just go over the basic rules and then there is one example that I'm going to do in this section. So before I went over the law of conservation of momentum, which says that the total initial momentum of a system equals the total final momentum for isolated systems. And this extends to collisions in 2 or 3D. In that case, the total momentum is conserved along each coordinate direction. So we'll need to apply the momentum conservation to the x direction and the y direction separately. So we have the sum of all the initial x components of the momentum for the system will equal the sum of the final x components, and the sum of all the initial y components will equal the sum of all the final y components. Since these are vectors, we'll break them down, and in a sense it's very similar to what we've done before for vector addition. So let's look at the example. A firecracker is at rest on the ground and is ignited. It explodes into 3 pieces. 2 of them are of equal mass and move off at an angle of 85.3 degrees to each other, both with a speed of 33.2 meters per second. The last piece has 4 times as much mass as the other pieces. What is the magnitude of the velocity of the last piece? Okay, so I've drawn 2 frames here, one for before the collision and one for after. Before the collision, we have one firecracker that's at rest, and after the collision, it splits into 3 pieces. I'm going to choose the x-axis to lie along the middle line between the 2 identical pieces after the collision. That will simplify our problem. Then we know the angle between them is 85.3 degrees, so if we divide that by 2, we can get the angle to that x-axis, which is 42.65 degrees. Now, let's interpret what it's saying about the mass. It's saying that after the collision, there's 2 identical pieces. We don't know their mass, so let's call it mass m. And then a third piece, this piece here, that has a mass of 4 times whatever that mass is. So if this is m and this is m, then this has to be 4m. And then before the collision, that's all together in one firecracker, and we have a total of 4 plus 1 plus 1, so 6m before the collision. Now this is 2D, so we want to apply conservation momentum in both coordinate directions. Overall, we have initial momentum equals final, and we can see the initial momentum is 0 in both directions. That mass is at rest initially. The firecracker is at rest. So let's look in the x direction. We have 0 equals m1 v1x plus m2 v2x plus m3 v3x equals 0, and then I can plug in the masses, 4m, m, and m for 2 and 3. And then rearranging for v1x, all of these m's cancel. So as expected, we don't need to know what the actual mass of the firecracker is. And then also notice that we were told that they move off at the same speed. So we have v2x and v3x, they're also in the same direction. So they're identical. We can put 2 times 33.2 meters per second, cos of 42.65, and then divided by that 4 factor from the mass of piece 1. Okay, and that leaves me with a velocity in the x direction of 12.2 meters per second for this larger piece. So it will move off with 12.2 meters per second after the collision. Now, looking at how I've drawn this diagram, it does look like it will be in the x direction, but let's show y. So we should check the y direction if we're not sure to see if there's a y component of the velocity, and if there was, we'd need to find its magnitude and direction or use component unit vector form. So our initial momentum in the y direction will have to equal the final momentum in the y direction. Initially, it's also 0, of course, so we'll get 0 equals this piece, so 4m v1y, and then I have plus m v2y plus m v3y equals 0. But one thing we do know is that because these pieces move off at the same angle to that horizontal line, one going up and one going down, how we've set up the problem, they will have equal and opposite y components of velocity here. So we'll have v2y equals negative v3y. So these terms will add to 0. And then we'll just get 4m v1y equals 0. So v1y is 0 as expected. So that larger piece of the firecracker moves off with only the x component of the velocity, which we found previously. It was 12.2 meters per second in the x direction. And that's going to be in the opposite direction to however those two other identical pieces were moving. Okay, so that's the only example I wanted to do in this section. You can practice some more examples on the homework, and then next we'll go on to center of mass.